Hi, I'm Raymond Hunter, and this video is about knowing when to use absolute values when simplifying radical expressions. Hey, I get it. It is confusing. So the first thing I'm going to do is I'm going to give you a hack to take care of all this. The hack is easy to use, easy to remember, and never misses. And then what I'm going to do is I'm going to walk you through each part of the hack to make sure you really do understand what you're doing when you simplify radical expressions. But the hack, entirely on its own, I call it EEO, entirely on its own, will do the job every single time. You can do one of these problems within seconds and never miss. All right, let's get to it. Here's the radical expression that we need to simplify. Notice that I did write 2 for the index for the square root. It's not necessary to write it, but it's also not incorrect to write it. In this case, I wrote it because it will make discussing the hack easier. It's kind of like writing x to the 1 instead of x, or log base 10, you write the 10 or you don't write the 10 depending on what you need. So the first thing I want to mention here is if your textbook is one of those where it says that the variables are only non-negative real numbers, then you don't need the absolute values at all. But if your textbook is one of those where it says the variables represent all real numbers, which includes negatives, then you must address the absolute value issue. Here's the EEO hack, which stands for even, even, odd. The first E represents the index of the radical. The second E represents the exponent of the variable that's under the radical, and the O represents the exponent of the variable once it's moved outside the radical. So if the index is even, and if the exponent under the radical is even, and if the exponent outside the radical is odd, then you must put absolute values there. So let's go ahead and do this problem. The first thing I want to do is square root each of the items underneath the radical. So square root of 49 is 7. The square root of w squared is w to the 1. The square root of x to the 6th is x cubed. The square root of y to the 4th is y squared. And the square root of z to the 8th is z to the 4th. Now, the next step, let's figure out who needs absolute values. So the index is even, and the w has an even exponent under the radical, and has a 1, which is odd, outside the radical. So we have even, even, odd. So the w to the 1 needs absolute values. Now let's look at the x. Again, the index is even. X is x to the 6, that's even. And then the x cubed outside, that 3 is odd. So we have even, even, odd. So x cubed needs absolute values. Now let's look at the y. Again, even index, y to the 4th, that's even. But outside we have y squared, so that's even as well. So we have even, even, even. The y squared does not need absolute values. Next, let's look at the z. So again, even index, z to the 8th, 8 is even, and then we have z to the 4th, 4 is even as well. So we have even, even, even. So z to the 4th does not need absolute values. The final step is I will clean things up and I will put the absolute value items together. When you have a product of absolute values, you can just put them all together and put the product in one set of absolute value bars. Now let's address each of the letters in the hack one at a time. We have E, E, O. The first E is the index of the radical. And when that index is even, the outcome of that radical must be positive. To understand why, let's first look at a radical with an odd index. So for example, the cube root of 8. Cube root of 8 is 2. Why? Because 2 times 2 times 2 is 8. And there's only one number that will make that happen. That's 2's. The cube root of negative 8 is negative 2. Why? Because negative 2 times negative 2 times negative 2 is negative 8. There's only one number that will make that happen. But now let's look at the square root of 4. How can we get the 4? We could do 2 times 2, in which case the outcome would be 2. But we could also get it by taking negative 2 times negative 2, in which case the outcome would be negative 2. The catch, though, is that the definition of radicals, when there's an even index, the definition says only include the positive answer. That would be called the principal root. So even though there's 2 possibilities, and the reason is because there are 2 possibilities, the definition says only include one of those. With the odd indexes, there's only one possible outcome, so there's no restriction on those. Now let's take a look at the square root of x squared. The square root of x squared would be x. But if it turned out that x was, say, negative 2, then I'm putting a negative 2 out there, and that's a negative value coming out of an even index radical. So I must put absolute values around that x to make sure that no matter what x is, the outcome is positive. Now let's take a look at the second E in EEO. That represents the exponent on the variable that's under the radical. If it turns out that that's an odd exponent, so let's say, for example, we're taking the square root of x cubed, and that has an odd exponent. And now let's suppose that x is a negative value, for example, -2. If we cube -2, we get -8. So that would be a negative under the radical, and that's just improper. So the problem would be improper in the first place. So when you have an odd exponent under the radical, you can assume that that letter is positive. And so then it's unnecessary to put absolute values around it outside the radical. Now let's look at the O in EOO. That represents the exponent on the variable that's outside the radical. If it turns out that that exponent's even, then it doesn't matter what the variable is, positive or negative, the outcome will be positive and absolute values are unnecessary. So let's say, for example, you have the square root of x to the 4th. That outcome will be x squared. And if it turns out x is, say, -2, and you square it, you get 4. There's no way that outcome will be anything other than positive. That's why the absolute values are not necessary in that case. Thanks for watching this video. If you found it was useful, consider liking it and subscribing to my channel so you can stay updated on new content. You can also drop a comment below because I'd love to hear your suggestions and any thoughts you might have for future videos.